Alright guys, I'm going to try to do a lot today. For those of you who are worried or concerned, I am feeling a little better, but not like I used to be. Well, needless to say, we still got some work to do, so let's get it done. So, for the triangle to the right, sine x equals 5 over 13. Well, sine, remember, from SOHCAHTOA, is opposite over hypotenuse. Okay? So, if that's the case, then if our reference angle is x, opposite would be this side. Hypotenuse would be up here. So its corresponding measurements will be 13 here, 5 over here. Okay? Well, we need to look for cosine x, and we're missing this side, which would be the adjacent side. Remember, labels is important. The only thing I can think of to do right now is Pythagorean Theorem. Y'all remember this from middle school. Excuse me. So, I have a leg, so that's going to be 5 squared plus b squared equals c squared, which is that 13. Alright, so that's 25 plus b squared. Let's see, 13 squared I think is 169. Subtract 25 from both sides. B squared equals, let me get my calculator. 144. Take the square root of that, and we get 12. So cosine x would be adjacent over hypotenuse, which would be 12 over 13. Let's check my work. They did Pythagorean Theorem as well. Cosine, yep. Good. Alright. We're going to look at this complementary angles idea. Remember, complementary means two angles add up to 90 degrees. Okay? Remember, supplementary means they add up to 180. Okay? We're going to chase this idea. So, 32 and 58 are complementary angles. Use your calculator to find sine 32 degrees and cosine 58 degrees. Again, you should be getting this practice in. Use your calculator. Alright. You should have got 53, or 0.53 and 0.53. Why would these be so? Well, remember, if we're looking at sine 32, that's opposite over hypotenuse, so that's a over c for this side. And over here, cosine 58, well, that's adjacent, which is the a over the c. So of course they're the same because they're using the same sides. Okay, these would be complementary. In fact, take notice, 32 and 58, add that up and what do you get? 90. Here's a list of sine and cosine relationships. Do you notice anything interesting? Just take a second and look at it. Alright. Notice these fractions are the same. And I'll change colors. And this one's the same as that one. Okay? So if x and y are complementary angles, then sine x is going to equal cosine y. You know, hence if I said, well, we'll get into it later. But that's just a relationship I want you to notice. And it's true because we just discovered they're using the same side ratios. Okay? Also, look at x and y. You're already using 90 degrees up in this corner, so of course the leftover is going to add up to 90 because the interior of a triangle adds up to 180. And that's why all these properties hold true, because all these right triangles are similar in some form or fashion. And that's where this trig function stuff comes from in the first place. So for any right triangle, will x degrees and y degrees always be complementary? Yes, because these will add up to 90 degrees. If x and y are complementary, will sine x always equal cosine y? Yes, because we've just proven that they're going to use the same side ratios. So for any complementary angles x and y, sine x equals cosine y, and cosine y equals sine y. So for example, if we have sine 30 degrees, its complementary would be what? 60, that's right. Because 30 plus 60 equals 90. If I did sine 45, what would its complementary be? 45. Because 45 plus 45 is 90 degrees. We're all just chasing this idea of complementary, okay? And it goes the other way. If I had cosine, and if I put 50 degrees here and I ask for the complementary trig function for this one, you would say sine 40, because again, 50 plus 40 equals 90 degrees. So, write the ratio fractions for each of the following. So, sine A would be right here, opposite, which is 21, over hypotenuse, which is 29, and cosine B would be adjacent, okay, over hypotenuse, which is 29. Okay? Remember, sine is opposite over hypotenuse, and cosine's adjacent over hypotenuse. Okay? So sine B, again, if I'm referencing, let me erase this. If I'm referencing this angle, sine B would be opposite over hypotenuse. So that's 20 over 29. And if I'm referencing cosine A, that's adjacent over hypotenuse. Labeling's important. You don't want to mix these up. That was the whole point of yesterday, was to get the labeling down. Okay? So again, we're going to write ratios here. I'm going to skip the labeling and go straight for the kill shot. So cosine A will be adjacent, which is 28, over hypotenuse, which is 53. And I guarantee you this sine B is again going to be 28, because it's opposite, over 53, the hypotenuse. They're going to be the same because these are complementary of each other. Cosine B, the adjacent side's 45, over the hypotenuse, which is 53. Sine A, that was up here, opposite, which is 45, and 53 is the hypotenuse. Notice the hypotenuse will never change names because it's always across from the 90 degrees. Alright, now we're going to start solving these things, okay? This is the real reason you learn trig functions, and you can use this in carpentry, projectiles, astrology. I think in my last video, old Greek magicians used this to discover how far the moon's away, how far the sun is away, and even how fast the moon's revolving around the earth. And even the earth revolving around the sun, because again, it's all similar triangles. So, every right triangle has one right angle, two acute angles, one hypotenuse, and two legs. To solve a right triangle means to determine the measure of all six parts. Excuse me. You can solve a right triangle if you know either of the following: one side length or one acute angle. Not or, and, excuse me. Or two side lengths. Okay. How could you find the length of the other leg, for example, 2? Obviously, Pythagorean Theorem, PT, a squared plus b squared equals c squared. And as long as you have two pieces of information, you can solve the rest. Obviously, you need to have 90 degrees here, or it all falls apart. Well, it really doesn't fall apart, but you'll learn that in pre-calculus if you ever get there. Unless you take AM/DM, because that's a fun course too. Talk about tires and financing and whatnot. So depending on which route you go. Anyway, there are several different ways to find the values of A and C using trig ratios. Can you figure out how to do that? Hint: write an equation with the trig ratio and then plug in what you know to find what you don't know. Again, that's algebra. Let's look at an example. Okay? Oops. Don't look at that. You have 58 degrees. Relative to the 58, 7 would be opposite. And then C would be the hypotenuse. In this instance, we're looking for C. Okay? Well, what trig function do you know has opposite and hypotenuse in it? That's right, sine. Okay? So sine 58 should equal opposite over hypotenuse. Plug in what you know. So 7 over c. Okay? Multiply both sides by c. Let me show you what that looks like. Oopsie daisy. And granted, I typed this up, but I mean, this, if it were to be stacked up, it'll look like this. And if you multiply both sides by c, these c's cancel, and you have 7 left over. And all of this is multiplied by c. Now, since it's being multiplied, you got to divide by sine 58 to get rid of it. Hence this next step. So this side we divided by sine 58. What you do to one side, you do to the other. Try to treat this as one whole thing. Well, then these cancel. So c equals 7 over sine 58. Next, you would want to grab your calculator, plug it in, and you'll get 8.25. Let me get rid of this thing. Cool. So, what would be different? What would be a different way to solve? Excuse me. What would be a different way to find the value of c? Cosine 32. Whoopsie daisy. Cosine 32. Where did the 32 come from? Oh yeah, complementary angles. This should be 32 degrees. And if that's 32 degrees, then this opposite turns into an adjacent side. Again, relative to 32 degrees. Okay, complete the problem, see if you get the same answer. You will, okay? Go ahead, if you want, go ahead and pause the video and try it, but I guarantee you'll get the same answer if you did it correctly. Well, this is how you solve for a missing length of a triangle. We'll get into angles here shortly. Oh, here we go. Here's the answer. Solved, divide, boom, same thing. Okay? Could you write a trig equation to find the value of A using only the information given on the triangle? Oops, you didn't see that. Well, the answer is yes. Because if you're relative to 32, A would be the opposite, and 7 would be the adjacent. And based on that, the fact that you have opposite and adjacent to work with, then it would be tangent. And if the roles were reversed, if you're referencing 58, then 7 would be opposite, and A would be adjacent. Okay? But you'd still get the same answer, depending on what you're looking for. Well, if you're looking for A, you'll obviously make the substitutions as needed. Okay? It's just going to take practice. This should be on the other worksheets, and I know y'all were having a hard time yesterday because you didn't know how to do this, but now you do. And you got to practice this stuff so you can do applications. Or none of this will make sense when we fly kites and go to the fire truck department. Anyway, this is me working it out. Again, opposite adjacent. Just focusing on the 58 for now. 7's opposite over the adjacent A. Multiply both sides by A. Divide by tangent 58. And we get 4.375. Same thing for this side. If we have tangent 32 degrees, opposite over adjacent, which is A over 7, times both sides by 7. 7 times tangent 32, 4.375. So it works out for both. Okay? Use trig functions to find the values of A and B. So go ahead and pause the video and give it a shot. Alright. So, if I'm looking for A, we'll do that one first. There's 2 routes we can go. We can either pick the 20 or the 70. It does not matter. I'm just going to pick the 20 for right now. So if I'm picking 20 as my reference angle, that means A is opposite, and this 9 is going to be the hypotenuse. So I would use sine. So sine 20 degrees is going to be opposite over hypotenuse. Plug in what you know. Opposite is just going to be A over the hypotenuse, which is 9. To get rid of the 9, I know the A and the 9 look alike. In order to get rid of the 9, multiply both sides by 9. The 9's cancel. A is left over on the right hand side. I am just going to get my calculator here and go 9 times sine 20, and I get 3.078, but that 7 is going to round, so 3.08. I'm going to change colors to green for B. Again, I'll try to leave these up. I'm going to leave the colors up here just to distinguish the difference. Alright, where the heck is B? I guess this is B. I guess it disappeared. Anyway, I'm going to keep using 20 as my reference, which makes B the adjacent side. And hypotenuse, well, that's going to stay the same. Hypotenuse is going to be the same for either one. Again, because it's opposite of the 90. Okay? Well, with that in mind, the fact I'm using adjacent and a hypotenuse here, that means I'm probably going to use cosine 20. And again, that's adjacent over hypotenuse. Plug in what you know. Cosine 20. Adjacent is B over 9 times both sides by 9 to get rid of it from the denominator. And remember, treat this whole cosine 20 as a whole thing. That's a S. 9's cancel. B should equal whatever 9 cosine 20 is. So let me plug that in. 9 times cosine 20. We get 8.457. That 7 is going to round that 5 up. So 8.46. Notice I'm using 2 decimal places for the sake of length, distances. Okay, that's your rule of thumb unless told otherwise. Let's compare our answers. So far, well, I didn't round it, but I did get the same thing here. And if I solved it the other way using cosine, I still got the same answer. So this would be a time for you to check your work. And if I solved for b, again, I got the same answer. And it doesn't matter which way you go with it, it still works out. Here's cosine 20, here's sine 70. Doesn't matter which route you go, but you've got to label these things in reference to whatever angle you're picking. If you mislabel it, you'll get the wrong answer. Okay? Almost done. What if we know the measure of the two sides and want to find the measure of the acute angle? Okay? This is the same triangle we were working with, so we know that x should be 20. Okay? Now how would you find it out if you didn't know? This is where trig inverses come into play. Okay? Here's your trig inverses, or inverse trig functions. Using trig function backwards to find the reference angle instead of side is called the inverse trig function. Inverse trig functions are written as sine inverse, cosine inverse, and tangent inverse. Okay? And notice it's being multiplied with those ratios. The ratios are still the same. Sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tangent is still opposite over adjacent. But now it's a matter of these two things switching places from before. Because remember before it was sine theta equaling opposite over hypotenuse. Well, these things, they've switched places now. So we can find the angle. Because remember, theta is that angle. Okay? So let's take it for a test drive. The ratio and the, yeah, see I put all that right there. The ratio and the theta swap places. The n minus 1, excuse me, the -1 indicates they're using the inverse. So look at your calculator, see if you can figure out how you could tell with the calculator you want to use the inverse function. Guys, you're going to have to hit shift and then that trig function you want to take the inverse of. And you'll notice a display up on your calculator screen. But again, if you're referencing this angle, that means this is going to be adjacent and this will be hypotenuse. Which trig function has adjacent over hypotenuse? Cosine. So I'm going to make my substitution. So 8.46 over 9 should equal my theta. Guys, I'm plugging it in as I see it. I'm hitting shift cosine inverse. And then I'm hitting my fraction key. And I'm putting 8.46 above 9. Closing my parentheses. Again, I'm making it look just like this. I hit enter. Now, my answer, I do get 19.948, etc., etc. Which, you know, if I was rounding this, it would be 19.9. Wow, let me try that again. All these extra dots are everywhere. When you're rounding degrees, you just go to the first decimal place, the tenths place. That 4 is not going to round that 9 up, so it'll be 19.9 degrees. Now granted, that's really close to 20, so I'm going to argue that we got what we're supposed to, which is 20 degrees. And guys, that's it when it comes to trig functions, okay? So again, we were right. We had to round it a little bit, but needless to say, we got the right answer. Now, I know my work here, I show that I got cosine x. Well, I picked the right trig function, plugged in what I know. Notice the x is what I don't know. If I want to solve for x, I got to swap places and use cosine inverse. So you can attack this that way, or just simply picking out the right inverse with the right side ratios. But again, it all takes practice, guys. You should have this homework over there on the table. You're going to compare sine and cosine B, complementary angles, and trig ratios. Should be practice over there for finding missing sides, and everything else should be hunky-dory. I think all this is a repeat, so I don't think you really need to worry about this stuff, but let me check, because I want y'all to be prepared. I already went over all this. Oh, I have no idea why these things are repeating. What's this? Yeah, y'all should have this practice assignment. Excuse me. So again, if you want to pause the video, try these out, and then unpause it, because here's the answers. Guess that's it. I should have the answer keys for y'all for tomorrow, but y'all work hard, be nice to Miss Skelton, and hopefully I'll be there tomorrow, okay? Y'all have a good day.